Okay, so what about when we divide radical expressions? So recall that when a fraction is multiplied by 1, its value does not change. Now 1 is a little bit of a sneaky misnomer here. So if I had 7 over 11 and I multiply it by 1, yeah, I would get 7 over 11. But when I say 1, I mean I can multiply it by 3 over 3. So that would be 21 over 33. So the value doesn't actually change. Like if I would put 7 divided by 11 and I would put 21 divided by 33, you would get the same decimal amount. Or I can say 7 divided by 11 and I multiply it by x over x, which is 7x over 11x. The value does not actually change. So this strategy can be used when dividing radical expressions. So it's called rationalizing the denominator, but we'll get to that. For example, 1 over root 2, I was okay with 1 over root 2, but it's not in a simplified form because we cannot have a radical in the denominator. Mathematicians don't like radicals in the denominator, though for me it's easiest to remember 1 over root 2 as the sine or cosine of 45. You need to get rid of the radical in the denominator. This is called rationalizing the denominator. So for some people in that unit, they said, wait a minute, why is the answer in the back of the book different? Well, it's because the answer in the back of the book is always rationalized, whereas sometimes your answers would not be. So to do this, multiply the top and the bottom by the radical in the denominator. So let's rationalize the denominator here. So that's the same thing as 1 over root 2 times root 2 over root 2. And actually there's not double multiplication here, it's just single multiplication. 1 times root 2 is root 2. Root 2 times root 2 is 2, and we're good. We don't have a radical in the denominator anymore. I'm going to go through these 3 questions and they become, they have increasing levels of difficulty. This one is still pretty easy. I'm just going to rationalize the denominator by multiplying by the radical in the denominator. So root 7 over root 7. I'm going to put brackets around this because it's a binomial and I want to make sure that the root 7 is distributed to both of those terms. So I have 5 times root 7 times root 7, so that is 5 times 7, plus 3 times root 7, all over root 7 times 7, which is simply 7. So many 7s. So that is 35 plus 3 root 7 over 7. And we're done. We're done and happy because even though we have a radical in the numerator, we don't have one in the denominator, and that's good. Now this one right here. Some people are going to want to multiply by 2 root 3, but then we have to go in and we need to simplify a little bit because it won't be in lowest terms. All we need to multiply by is that radical bit. So root 3 over root 3. I'm going to put this around brackets around the numerator again because it's a binomial and I want to make sure that the radical gets distributed to both of those terms. So I have 2 times root 3 times root 3, 2 times 3, plus 1 times root 3, which is simply root 3, all over 2 times root 3 times root 3, which is 3. So 6 plus root 3 over 6, done. We don't have a radical in the denominator anymore. So say if we multiplied this by 2 root 3. So I'm just gonna do kind of like an alternate universe here. What happened if we did multiply by 2 root 3? So 2 root 3 plus 1 all over 2 root 3. And I'm gonna, in this alternate universe, I'm gonna multiply. I'm gonna rationalize the denominator by multiplying by 2 root 3, and I'll show you why this is the wrong way and how this actually creates a little bit more work for you. So 2 root 3 times 2 root 3, which is 4 times 3, because root 3 times root 3 is 3, plus 2 root 3, because 1 times 2 root 3 is 2 root 3, times 4 times 3. So that's 12 plus 2, 2 root 3 over 12. But we have a common factor between these, so I go 2 times 6 plus root 3 over 2 times 6. You don't have to do this, but it makes the canceling a lot easier, which is 6 plus root 3 over 6. So do you see how that's like when we just compare the number of lines? Here, this is how long it takes if you just multiply by the radical. This is how long it takes if you multiply by the mixed radical. Okay, so I don't want you to be multiplying by the mixed radical, just multiply by that radical. Last but not least, this one is a little bit of an extra step because this radical is not in mixed radical form yet. We can simplify further. So 6 root 2 minus 4 root 3 over, and I have 9 times 2. So the square root of 9 times 2 is the same thing as square root of 18, so I have 6 root 2 minus 4 root 3 all over 3 root 2. Now, part of me wants to cancel, wants to be able to cancel something here, but we can't. I can cancel this with this, but I can't because this term also has to have a factor of root 2 for me to be able to do that. And some of you will want to cancel this 3 and put a 2 here, but the only way that you can do it is if both terms in the numerator can be, you can factor out a factor of 3, and you can't with a 4. So don't do anything here. So now what I want to do is I want to rationalize the denominator by just multiplying by the radical bit. So root 2 over root 2. I'm going to put a bracket around the numerator because it's a binomial, and I want to distribute this radical to both. So that becomes 6 times the square root of 4, which is 2. So 6 times 2 minus 4 times 3 times 2, which is 6, all over 3 times root 2, which is 2. So that becomes 12 minus 4 root 6 over 6. Now here's the thing. All of these terms have a factor of 2. So I'm going to factor out a 2 from the first two in the numerator. So 2 times 6 minus 2 root 6. Notice that I don't take anything, I don't factor out a 2 from underneath a radical. It's just I'm factoring out a 2 which comes from the coefficient, all over 2 times 3, which just makes it easy for me to cancel. So my final answer here is 6 minus 2 root 6 over 3. I'm done.